Hello everyone, welcome to my channel ProChem Academy. Now today I will discuss about the spectrum of hydrogen atom. Okay, that means the topic of atomic structure. Now last day we have learned in last video that the energy of the electron which is revolving around nucleus in nth orbit, it is given by En equal minus 2 pi square mz square to the power 4 by n square h square. Now we know from Bohr's theory that when an electron jumps from lower energy state to higher energy state, that means one electronic state to another electronic state, it will absorb energy or radiate energy. Now if it goes from lower energy state to higher energy state or higher energy state to lower energy state, then the corresponding spectrum we will get, okay, that is the difference of the energy. Okay, if an electron is in the lower energy state or in the higher energy state. Okay, so if the electron is in higher energy state, here N2, this is the higher energy state N2, this one E1. Here the energy is E2, here the energy is E1. Okay, so if the electron jumps from higher energy to lower energy, then emission will be there. That means energy will be emitted, and that will come to a particular region. A region of the wavelength, that is the spectrum. So corresponding spectrum will get if the electron jumps from higher energy state to lower energy state. So let the electron jumps from N2 to N1. Okay, it can jump from N1 to N2 also. So when the electron jumps from N2 to N1, we will get the emission spectrum. Okay, so what is that? It is the difference of the energy. Now the difference of the energy from N2 to E1, that is E2 to E1, is E2 minus E1, and it is given by del E, that is difference, change in the energy. Now this E2 means minus 2 pi square mz square to the power 4 by n2 square h square. Okay, this minus minus plus 2 pi square m z square to the power 4 by n1 square h square. Okay, this is the difference. Now we can write it like this: 2 pi square m z square to the power 4 by n1 square h square minus 2 pi square m z square to the power 4 by n2 square h square. Now these all are constant except n1 and n2. So we can take common: minus 2 pi square m z square to the power 4 by h square. Here 1 by n1 square minus 1 by n2 square. So this is nothing but del E. Okay, now from the quantum theory of Max Planck is given as theory, that is the quantum theory. He told that the energy of a electron or energy of a particle is nothing but h nu. That means energy of a photon like particle is h nu. So this E can be replaced by h nu. That means from the quantum theory we know that E equal h nu. So this, the change of energy also will be the h nu. Okay, so we can put here h nu. So we'll get h nu equal to pi square m z square to the power 4 by h square, 1 by n1 square minus 1 by n2 square. We are going to put derive a relation of the spectrum of hydrogen. Okay, of the spectrum of hydrogen. Okay, so I think you have written this one. Okay, so just erase it. Okay, so here now this h nu, we are going to derive a relation of the lambda, that means wavelength of the light. Okay, that means wavelength. Now we know that this nu is the frequency, and nu equals c by lambda. Where c is the velocity of the light and lambda is the wavelength of the light wave. Okay, so here hc by lambda we can write equal to pi square m z square to the power 4 by h square, 1 by n1 square minus 1 by n2 square. Okay, so now what we can do, we can take the value of 1 by lambda. So what we will get? 2 pi square m z square to the power 4 by c h cube. Now if it is as it is for hydrogen atom, the z will be 1, as it is for hydrogen atom, the Z will be 1. So what we will do, we put 1 instead of Z. Okay, so we'll get 1 by lambda equal 2 pi square m 1 square e to the power 4 by ch cube. Okay, 1 by n1 square minus 1 by n2 square. Okay, then now this is nothing but, this constant is nothing but Rydberg constant. This is called a constant, that is called RH. Okay, 2 pi square m e to the power 4 by ch cube. And theoretically it has a value, that is or experimentally it has value. This is the theoretical value, 109647. Okay, this kind of value is there, centimeter inverse, and it is quite comparable with the experimental value. Okay, it is quite comparable with the experimental value, that is 109677.7. 109677.7 centimeter inverse. Okay, so that is the Rydberg constant. Okay, so 1 by lambda equal RH 1 by n1 square minus 1 by n2 square. Someone will tell that the value will be 109737 like that. Okay, that is also correct. So this one is 1 by lambda. This is the relation of the spectrum. Now this 1 by lambda is nothing but wave number, and that is denoted by nu bar, wave number of wave. Okay, that is RH 1 by n1 square minus 1 by n2 square. So this is nothing but wave number. This is nothing but wave number. So this relation is important to calculate the wavelength when the energy is, that means electron is transition from the lower energy state to higher energy state, that means one energy state to another energy state. Okay, now different value of lambda will give different spectral line. Okay, different value of lambda will give different spectral line. Okay, that depends on the value of n1 and n2. Okay, those are called the spectral line. So if here this 1 by lambda equal this relation, we have to remember. Now if the n1 is 1, that means electron is going from one n1, that is one energy state to the, that means first energy state to the second, third, fourth, or so on energy state. This is the corresponding spectral line we will get, that will be called as Lyman series of spectral line. If n1 equal to, and it is going to n2 is 3, 4, 5, the series we will get, it will be Balmer series. Okay, it will be Balmer series. Okay, if the n1 is 3 and n2 is something 4, 5, 6 dot, it will be Paschen series. Okay, it will be Paschen series. Okay, I think you are understanding. So this is Paschen series. Again, if n1 is 4 and n2 is 5, 6, 7 dot, it will be bracket series. Okay, it will be bracket series. Okay, and if n1 equals 5 and n2 equals 6, 7 dot, it will be P fund series. So these are the spectral lines. Okay, these are the spectral lines of hydrogen atom. So numerical problem regarding this we will discuss next day. So that can also come in your exam. It is very important for all kind of joint tenors, NEET and board exams also. So thank you for today's video. Okay, so if you have any doubt, you can ask me over comment box. So, and if you like this video, then do like, comment and subscribe my channel. Thank you.